11.3, we are up to 1b. They want us to find the Maclaurin series and its convergence, and here's the function. So again, we're going to start the same process here. We're going to start taking derivatives. So starting, this is centered at x equals 0. Starting with the function evaluated at 0, it's 1. The first derivative is going to be, that's 1 minus x to the negative 1, so negative 1, 1 minus x to the negative 2 times a negative, so positive. So if I stick a 0 in there, I get 1 again. The second derivative is going to be negative 2, 1 minus x to the negative 3 times a negative sign, and I'm going to get 2. The third derivative, and you're looking at it going, where is the pattern here? Negative 6, 1 minus x to the negative 4 times a negative 1 makes it positive 6. I'm going to go one more. I think you'll see it after this. The fourth derivative, negative 24, 1 minus x to the negative 5 times the derivative of the junk is negative 1, so positive. All right, so what you're supposed to recognize here is that this is 4 factorial, this is 3 factorial, this is 2 factorial, this would be 1 factorial, and this would be 0 factorial. So writing out the polynomial, I start out with 1. It's the f of x term. Then I'm going to add to it 1. 1 factorial is just 1, so 1x over 1 factorial. Okay, so gone. Then I have the second derivative is 2 factorial, x squared over 2 factorial. Then I have 3 factorial, x cubed over... Okay, I see what's happening. All the factorials are going to cancel. And so my summation is actually very easy to write, plus dot dot dot. K equals 0 to infinity, and all I'm doing is taking x and raising it to the k, and that will generate the terms. Now, we could apply the ratio test on this one, but we've already looked at this particular problem, the 1 over 1 minus x, and it converges for everything, or for less than 1. So if I do the ratio test just to show you, not everything, less than 1, the limit as k goes to infinity, it's going to be x to the k plus 1 over x to the k, which leaves me with an x when I reduce this. And the only time it converges, according to the ratio test, is when it's less than 1. So my radius is 1, my interval is negative 1 to positive 1. Okay, example 2. A center other than 0. Find the first 4 non-zero terms of the Taylor series for f of x equals the cube root of x centered at 8. Okay, so I start out with the function. I plug in 8 and I get 2. I take the first derivative. That's going to be 1/3 x to the negative 2/3 evaluated at 8. That's 1/3 1 over the cube root of 8 squared. So I get 1 over, cube root of 8 is 2, 2 squared is 4, 4 times 3 is 12. Okay, second derivative. That's going to be negative 2/9 x to the negative 5/3 evaluated at 8. So negative 2/9 times 1 over the cube root of 8 to the 5th. That gives me 2 to the 5th is 32. Reduced by 2, that's 16. I get negative 1 over 144. Yeah, I don't see a pattern yet. Now, I want the first 4 terms, so I only have to go to 3 derivatives. So even if I don't see a pattern, it's fine. This derivative is going to be 10 over 27 x to the negative 8/3 evaluated at 8. 10 over 27 times 1 over the cube root of 8 to the 8th Goodness. That's 2 to the 8th times the 27. Okay, using a calculator, I would end up with that number. So now we're going to make the power series. So we're going to call this P sub 4. The book uses f of x. I've always used P for polynomial. First function, it's 2. Then it's going to have that factorial of a 0 on the bottom. The next one is going to have a 1/12. Now, it is centered at 8, so I've got to change the x to an x minus 8. It's to the first, and it's over 1 factorial, so I'm not writing that. The next derivative is negative 1 over 144. It's x minus 8 squared. Oh, and it's over 2 factorial. And then I'm going to go to the next term, which would be positive 5 over 3, 4, 5, 6, x minus 8 cubed over 3 factorial. If we clean this mess up, and I cheat and look in the book, this is 2. This is just 1/12 x minus 8. This is negative 1 over 288 x minus 8 squared, and here's the one where I have to cheat. This one turns out to be 5 over 6 times 3, 4, 5, 6. 20,736 x minus 8 cubed. So that's the first 4 non-zero terms.